Section 2.3 is on polynomial functions, and the first part here is the definition. It says the function defined by f of x equals a sub n x to the n plus a sub n minus 1 x to the n minus 1 on down to a sub 2 x squared plus a sub 1x plus a sub 0, where n is a non-negative integer and your values for a are real numbers, and this is called a polynomial function. The coefficient of the variable to the highest power is called the leading coefficient. Usually we say the leading coefficient is the first one, and if the polynomial is written in the correct order, then it will be the first one, but we say it's the variable of the highest power. Okay, as far as the definition of this in my words, I would say that in order for a function to be a polynomial function, we have to have all of the exponents positive, and there can be no variables in the denominator of a fraction. And also, because it says that n is a non-negative integer, this means that your exponents cannot be fractions. So all positive exponents but no fractions, and you can't have variables in the denominator of a fraction because again that would make those negative. So you're going to have to be able to look at a function and determine whether or not it is a polynomial function. So if we look at the first one, f of x is equal to 5x plus 2x to the fifth. Okay, I have positive exponents, I don't have any variables in the denominator of a fraction, and my exponents are integers. So this would be a polynomial function. The leading coefficient for this function would be the 2x to the fifth, because that's the highest exponent we have. Okay, number 2, f of x equals 7 minus 1 over x cubed. Okay, we have a variable in the denominator of a fraction. If I brought it to the top, it would make it be a negative 3, so this would be no. This is not a polynomial function. Okay, if we look at number 3, 5x to the 7th minus x squared plus 5 over 4x, it's okay to have fractional coefficients, just not exponents. So we have a positive 7, a positive 2, a positive 1, so this would be yes. This is a polynomial function. And the leading coefficient would be 5x to the 7th, or the 5. Number 4, f of x equals x to the 5/4 minus x to the 4th minus 7. Because we have a fractional exponent, this is not a polynomial function. Okay, some characteristics of a polynomial function that you need to know. This says that the graphs of polynomial functions of degree 2 or higher are smooth and continuous. Okay, smooth meaning that it has only rounded curves, no sharp corners or sharp turns in the graph, and continuous means that it has no breaks in the graph. You can draw the graph without lifting your pencil from the paper. Okay, notice we say that graphs of polynomial functions of degree 2. So a parabola with a degree of 2 is also considered to be a polynomial function. Okay, a straight line is also considered to be a polynomial function. Alright, some of the problems you'll have on the homework will say to determine whether the graph shown is the graph of a polynomial function. Okay, if I look at part A, it's not a parabola, it's a straight and then a corner back up. This is actually the absolute value function. So this is not a polynomial function because it's not smooth. Okay, if I look at B, I have a smooth turn here where I have a minimum, a smooth turn, and then another smooth turn. So this would be a polynomial function. Okay, and then if I look at C, they are smooth if I look at each piece, but because I have a break in the graph, a part where it's discontinuous, this would make this not a polynomial function.